Sure. Ready to go?
Yep, go for it.
Good evening, everyone. Hopefully everybody can hear me okay and see my slides. So my name is John Dunbar and I'm a doctoral student at NUI Galway, working in the Venom Systems and Proteomics Lab under the supervision of Dr. Michelle Dugan. And I focused the last 4 years of my research on the false widow spider, Steatoda nobilis. And unfortunately, this is most people's introduction to this spider, and it's been hammered all over the tabloids for the last decade or so in Britain and Ireland. And the first introduction people get to the spider is that it's attacking people in their homes, it's causing horrific wounds, necrosis, limbs being amputated, terrible bacterial infections, and even associated with deaths in the press. But there is actually very little scientific evaluation of these claims, and there's very little known, in fact, about the false widow spider other than some ecological aspects. So most of my research is to kind of study the impacts of the medical significance. But this is important to actually establish some of the ecological aspects, because the first thing we really need to know is how likely are you to actually come in contact with one. So imagine if you have an organism that's really, really dangerous, but if there's only like a very few of them there, that's not really going to be any issue. So the first task was to understand how widespread they are. So this is one here. This is the size they can get to. This is probably one of the largest sizes that we've actually found. And just to recap on their distribution, so they apparently originate in the Canary Islands and Madeira Islands, and about 140 years ago they were first recorded in southern England. And what's interesting is they remained relatively low-key. A few reports of them across southern England over the last century, but pretty much up until about 20, 30 years ago, they weren't really that abundant. And then they started to really increase in range and increase in population densities. And this correlates with their sudden appearance in Ireland in 1998, and also across the world. So they're now recorded across southern Europe, the Mediterranean, and the Middle East, as far as Turkey and as far as Iran. They're also found in the western coast of America and also in 3 countries in South America. On a recent field trip to Morocco, we were also finding populations of them there. So they are now globalized, but it's the recent activity we find very interesting, because they weren't considered problematic at all, and all of a sudden, correlating with their increase, we see these reports of people being bitten. What's interesting is we know that they're closely related to black widows, and what makes and gives black widows their reputation is that they possess a very potent neurotoxin called alpha-latrotoxin, and alpha-latrotoxin targets the presynaptic nerve and induces a massive neurotransmitter release. And this can actually trigger neuromuscular paralysis. So one of the first jobs we did was to characterize the morphology of Steatoda nobilis, look at the very different characteristics of individuals within the same population, and actually demonstrate how diverse they are, because it's very difficult for people who are not familiar with them to identify them, because they pretty much, you can see a lot of similarities between them, but quite a lot of them look very, very different to each other. So one of the other things we wanted to do was to look at their reproductive rate. This has been reported on previously by other authors, but we increased this by analysing 50 egg sacs. And what we found was the average egg sac will produce 94 eggs, and within a range of 34 to 208 eggs. So maximum, the 208 eggs is quite remarkable for a single spider sac. Interestingly, they can have several of these egg sacs a year. So what we found was we carried out a survey, and from the original single county they were reported in the late 1990s, 2017 we recorded them in another 15 counties, and extremely abundant in east coastal counties like Dublin and Wicklow. And it's been noted already that they do have quite an exceptional longevity. They can actually live, at least in captivity, up to 5 years. And as we documented, a fast reproductive rate, potentially reaching up to 1,000 babies a year. But they are actually cold tolerant, so each month in the year we'll actually see these. And even in the coldest months, okay, they dwindle down in numbers, but you can still see them under webs and induce activity even in the coldest months. And we know that they have a fast acting neurotoxic venom, and willing and capable to subdue quite a diverse range of prey types. So if we look at some of the studies, I'm just going to, a lot of these studies are not completed or not published, so I'm just going to briefly touch on some of them just to illustrate the work we're doing. So in our lab, this is one of the studies carried out by Eva. It's basically looking at the dispersal behavior. So using space and time modeling, we're actually able to see that they're very different to some of the other false-footed spiders that are actually in Ireland well over a century, but nowhere near as widespread as Steatoda nobilis. So we wanted to see what makes these different. And what we find initially is that they have a non-random dispersal, which is really interesting, that they cluster together and they stay together, and there seems to be some cooperative behavior. So this initially from the get-go is demonstrating some ability to outdo other spiders. From our initial survey, this was continued then in 2019 by Cora, and we can see that there is an increase in occurrence in new counties and also in population density. Just to give you an indication of some of the habitats that we find them in. So right across Dublin, I wouldn't be surprised if almost every single garden, house, city, town, wall, bridge, fence, park railings, everywhere seems to have these. And they're quite dense and abundant, and even in some of the locations here. So typically where metal meets concrete, or concrete or metal meets wood, so somewhere where there's an artificial heat conductor, heat trap, it'll really thrive there. And once there's a little bit of a crevice for them to hide, they can remain there all through the year. So this is a picture of my own house, the side door. And what I noticed there last winter was there was one just up in the top corner, and then a few months later this other one joined it. And so every evening, once it gets dark, these two come out onto their webs. And as you can see, the top right corner, this one's actually produced an egg chamber and an egg sac. So I now have lots of little false-footed spiders all around the outside of my house, and they're also inside. This is my wife's car, where I was changing the water, topping up the water, and I noticed a big web. So I dropped a wood louse on it, and sure enough, it's a false-footed spider. I found them in the boot of the car on my child's buggy. There's nowhere that they would. So this is recording from one night I was sampling, just to give you an idea of density. That's 3, 4, 5, 6, 7. So just in a few feet, there's 7 adult Steatoda nobilis, and this went on for hundreds of meters. And what's interesting is only possibly 3 weeks before I recorded this, I actually was already here and actually collected every adult I could find. And it just indicates how quickly they come back. So they feed on a diverse range of prey. This is something that we observed regularly. Everything from centipedes, big shield bugs, other spiders, other hymenopterans, other venomous bugs. They're very ambitious. They will take down anything they can overpower, and willing to try it. What's more interesting is that we actually documented feeding on a lizard. This is not unusual for latrodectony spiders, so false widows and black widows. They are known to do this quite, not too regularly, but they're well documented for it. But what's interesting here is this happened in Ireland, and this is not something that we're used to. There's never been a case of our typical house spiders preying on lizards. So this is something new that's happening. It's not to say it's common, but something that we should take notice about. Just to illustrate, demonstrate that how they can do this. So this is not Steatoda nobilis. This is actually a tiny little false widow spider called Steatoda triangulosa. This footage was taken in the Mediterranean and sent to us by the photographer. And what's cool is we have a video of the actual kill, but soon after he set up the camera again to catch how the spider actually pulled it off the ground. So I'll just click this here. You can watch. So it's quite remarkable how they can, first of all, subdue very rapidly large vertebrates and then pull them up onto the webs. When I on my sampling, I actually recorded this. This is in about 2 or 3 feet above my head in a tree in a graveyard in Lucan. Where you can see Steatoda nobilis has actually subdued a large joint house spider and is just finishing wrapping it up. I didn't get to video some of these, but I've seen when I've witnessed them taking other spiders, and the speed in which they do it. They use this attack wrap strategy, and it's really impressive. So to investigate these further, their effects to other spiders. One of the things that I had to do was to overcome my own actual fear of spiders, because even though I've worked on them a lot, they do creep me out. So this is a little video of the first time I actually had to pin a giant house spider so that we could inject it with Steatoda nobilis venom. So upon that, this is work that was carried out by ISTA. Again, I'm not going to go into too much detail, just to kind of summarize some of the work being done. So the venom with Steatoda nobilis is actually extremely potent to at least 3 of our native species. So these are species that we'll see regularly around the home and garden. It is to a degree resistant to its own venom. But significantly more potent than the giant house spider and the laceweb spider. And what's interesting is we also wanted to see how they fare out in actual delivering these bites. So if you actually cage them together, what will the outcome be like? So this was carried out on a number of species, and sure enough, Steatoda nobilis turned out to be really competitive against native spiders. Other researchers are noticing this. I'm not going to go into detail in these, but just to note that other researchers are concerned and kind of raising similar questions to us. I'm just trying to delete this thing here. So one of the questions that Clive Hammer is asking is, although they're here over 140 years, where in England, are we being complacent because nothing has really happened in more than 100 years? And are we just not noticing this sudden rise and potential problem from it? And also, really interesting study emerged where they looked at modelling to identify potential habitats for Steatoda nobilis around the world. And this predicted that it is potentially could be one of the most invasive species of spider in the world. Looking at some data where in the UK, it's wondered whether the media is actually causing the hype about Steatoda nobilis. But this work demonstrates that there is a correlation with data produced by the British Ecological Society from the Spider Recording Scheme. And it seems that the media reports follow the actual reports from the public, not the other way around, which is quite interesting. This is a video of one female who actually got into the hole of a fence. We're collecting them along these fences, but this particular hole was smaller than the others. So it's actually climbed in, but as she grew and started to produce eggs, she contributed. So you can see she was struggling to try and wrap up her food. And then once we left that there, she then has to turn around and try and get her fangs out to feed from the outside. So this is kind of just more funny to demonstrate.
It's tough there.
So what we do is we basically go around once it gets dark and just snatch all these spiders from their webs, and in one night we could probably, in space of 2 or 3 hours, we could probably produce 100 to 200 specimens, and that's leaving behind many hundreds of juvenile and subadult specimens. And we could go back to the same area a week later, 2 weeks later. It's quite abundant again. And then we bring them back to the lab and we'll extract venom for our research. So some of the work that we've done is to look then at the medical records, to look at bite reports and look at symptomology, to try and characterize what are the actual effects. Because believe it or not, up until 2017, there was actually only 2 actual medically assessed records of these bites in the world. One in the UK in 1991, and the other one was in Chile in 2016. So while the media are picking up on all these apparent and alleged bite cases that are pretty much mostly non-verifiable, the medical records suggest that they do have potency to the venom, particularly the first one, which more concerning is that they had a systemic neurotoxic effects, but overall not life-threatening or similar to black widows, but not anything too concerning. But the fact that it can have a systemic effect is something to we should take note of, because that's only 2 cases. It's not really a good sample size to judge everything on. But when we compiled 5 more, what we found was, in common with the previous cases and other Steatoda species, the most common symptom was pain, immediate, mild to intense pain, erythema, so redness around the bite site, and swelling. But what's interesting is we noted one case of minor necrosis. This is not debilitating necrotic wounds. This is actually really just a tiny wound that developed at the bite site. Nothing to really worry about. It all just healed up on its own in a few days. But what's interesting is when commonly discussed, this venom is deemed to be totally neurotoxic. So why all of a sudden are we seeing these wounds? So it's worth investigating, if there is some sort of cytotoxicity effect of the venom as well, and to determine can it produce necrosis. So one of the things we looked at was on cells. So these are just quickly some mammalian blood cells. And as you can see, with a dose and time dependent, there is actually, you can see cell death. And when we look at some horse blood agars, we can see that, again, when we increase the volume of venom, we do see a hemolytic effect, an increase in hemolytic effect. Going to skin cells, human skin cells, using the HatCat cell lines. This work was carried out in the College of Medicine in NUI Galway with Doctors Kerry Thompson and Alana Stanley and Alex Black in the Department of Anatomy. And what we did was we looked at these cells, human cells, and I'll just go back. If you look at the box on the right, in the top left corner, we see the timeline as it goes up to 30 minutes. You add the venom and immediately you see this kind of blebbing effect. And then again, not to go into detail, but just to demonstrate here that there is an effect where the venom is actually killing cells and reducing cellular activity, but also interfering through the cytoskeleton and the titan adherence junctions. And when we look at the mitochondria, again on the right box, the top left corner, once it reaches 30 minutes and everything's fine and we add the venom, we see the mitochondria die off. So this is really interesting. So there is a direct effect from this venom. And we also see this in the case reports. So it's not just happening in cell culture and stuff like that. It is actually happening in real life to real victims. This was a female who was bitten on her left breast, and the spider was actually trapped in her clothing. And at each bite site, this little necrotic wound developed. But again, it was almost identical to the first case and healed up pretty well as well, with no debilitating effects at all. So the victim was not concerned, but brought it to the attention because it was quite unusual. So when we characterized the venom with our colleagues in the University of Liège, we used a venomics approach where we characterized the RNA transcriptome and compared this with the proteomics. And what we found initially was that there was huge overlap between the venom of Steatoda nobilis and black widow spiders. And what we find is that there's actually quite a range of enzymes that may play a role in digestion of prey, perhaps, but also helping to spread the venom around the body. That may not have a detrimental effect in a sense, but could possibly be responsible in localized cell death. But we did find a huge amount of alpha-lateral toxins. We are still working on assays, LD50s and so on, to determine the potency. We're not saying that they're exactly as potent as black widows, but there is certainly some potency to it. But what's interesting is we found more alpha-lateral toxin in Steatoda nobilis than in black widows. When we look at some actual case reports, this is a new case series that we're compiling. This is a typical bite, what you see here. You see the red arrows pointing to the bite site, which the fangs are tiny. You nearly won't see actual bite marks, but you'll see this white pale area that will develop. It'll bubble up a little bit, and then you'll get this redness that will radiate from the bite site, indicated with the blue arrow. Accompanying this could be symptoms like most likely a very intense sharp pain, but also some sweatiness, itchiness, and so on. Sometimes there's no swelling, sometimes the whole limb swells up. But what we're starting to see is compiling these to bring the whole global case series to 23 bite cases that are actually 100% confirmed cases. We're starting to see some symptoms that are getting a little bit more serious, some that are in common with black widows. And we have even some cases where people experienced debilitating pain. Some people hospitalized. The pain was unbearable for a number of days. We had one lady who felt pain on her hip, and she stood up. They found a fuzz with a spider in her clothing. But when she stood up, she had intense pain shooting up to her neck and jawline and then down to her ankle. So this is not something that's just harmless and localized. This is something that in some cases could have a much more potent effect. We've had victims with tremors, facial flushing, and then we get into an area where some victims have developed cellulitis and dermatitis. What's interesting is 57% of the bites were by females, and 43% of the bites by males. And what's interesting about this is true black widows, it's only the females that are associated with bites, and males are absolutely tiny in comparison to the females. and it's believed that the fangs are so small they can't penetrate human skin. So, but just to give you an indication, the males and females are actually a very similar size. And the males are equally, nearly equally in common with giving bites as females. And what's interesting is you can see the pictures here, the fangs are quite different. I don't know why, but I just thought I'd show you these because I thought they were very interesting. All bites occurred in and around the home, except for the original case, which the victim was already in hospital in the bed when she got bitten on the neck. 57% of the victims were either asleep in bed or resting on a couch. 31% was trapped in clothing, so they were doing something in the house and then they got bitten and found a spider within their clothing. And then there was one case in gardening, handling the spider and performing house maintenance. On the bottom right, you can see this image of a small juvenile spider. This is actually the spider that was implicated in one of our bite reports. It's just a little juvenile. So it's only 2 millimeters long in body size. And when we raised this up in the lab, it turned out to be a male. And the symptoms were not like overly intense or anything like that, but they were classic redness and pain. But what's interesting is the size of the spider was absolutely tiny, because I've often heard that adult spiders are too small to penetrate human skin, which we know it's not true, but even look at the size of this little one. And then we also noted that most of the cases of bites are occurring in, are occurring in summer. One of the things that we're interested in is the effects of the venom. So we should expect that every single individual who's bitten could have variation in their symptom onsets to another person, because everybody's different and every spider is different. So we look at everything from individual pathophysiological response. It's like, bacteria. When people encounter bacteria, their immune system, it depends on their immune status at the time, whether they become susceptible or not, amongst other factors. It's the same with venomation. Your immune status can play a role. It's nothing to do with whether you're allergic or not, but also other things like the replenishment of the venom. So when did the spider last bite something and use its venom, and how much venom has it got left? Because quantity of the venom is likely to play a very important role in venomation and the symptom onsets. And what we did was we analysed the venom extractions of 550 wild caught. So we didn't keep them in a lab to feed them up and then find out what's the maximum amount. We took a snapshot of a wild population, and what we found was that the maximum yield was just over half of microliter venom, which is absolutely tiny. Very impressive because of the range of symptoms this can induce. But when we consider that was only a handful of specimens that had that amount, most of them had less than half of that. And then you had a few that had almost no venom at all. So it kind of indicates that if you're bitten by a spider, you've got a more likely chance that you're going to have like a middle range of symptoms, because you're more likely to be bitten by one that has only like a half a tank of venom. And this is what we see with our case reports. We actually see that most cases are actually very kind of mild. They will induce pain, sharp pain, redness, and maybe some itchiness and sweating. But by the end of the day, typically this is all resolved and no issues. Then on the other end of the scale, we've got some cases where the victims are almost embarrassed to report them because they're so minor. And then on another end of the scale, we have some cases that are extremely serious. So, but if you're bitten by a false-worded spider and you have mild symptoms, that's not proof that they're not dangerous. That's just an example of a mild case. What's interesting is that we did find a correlation between the body size and the venom yield. So the bigger the spider, the more venom, which is probably not unexpected, and also that the females are more likely to produce more venom. So just to finish up, one of the other big issues in the media is, can these spiders induce a bacterial infection? Because these are quite commonly associated with them in the media, but again, not verified by the scientific community. So we took up this study, myself and Nayaz and colleagues in the microbiology department in NUI Galway. And the first thing we did was we sampled specimens of Steatoda nobilis, but also 2 of the other spiders that we find around our homes and gardens that are also likely to give you a bite. But these are also spiders that people don't regularly complain about, because while they're capable of giving you a bite, it's not common for them to do so. But sure enough, to no surprise, they do carry bacteria on their bodies and on their fangs. And we should expect that they would. They live in the environment and they feed on prey that carry bacteria. Spiders are also known, and we've documented them feeding on carrion. I've raised spiders to adulthood from babies in the lab by feeding them bits of chicken. And so they readily take carrion. I've seen them feeding on prey several days to a week later. So it's no surprise that they'll have bacteria on their fangs. But when we actually focused on Steatoda nobilis, we found that there's quite a lot of pathogenic bacteria marked there with the red arrows. And when we looked, because some of the complaints are that the victims are not responding to antibiotics, so we actually tested these strains against antibiotics and found that quite a lot of them were antibiotic resistant. And this may actually play a role with prolonging the symptomology between the effects of the venom and then on top of this. So if you imagine you've got the venom has the ability to kill localized cells, and then you add bacteria into this, and then on top of that they're resistant to antibiotics. You can imagine the kind of outcome this would be for somebody. And in the media, we see this regularly, where people are nearly at the stage where they're told that they've had their legs or arms will need to be amputated. The problem with the stories in the media is there's no urgency to actually identify that spider. So true enough, when we look at some of the case reports, we were working closely with one victim who actually did have one of these really intense bites. She was bitten when she walked across to her room and found that there was pain in her leg, and when she rolled up her trouser leg, she can see the spider. Well, as she tried to get it, the spider kept running up instead of down. So she kept putting up the trouser leg, but every time she did so, she pinned the spider, and that induced the spider to bite again. So she was bitten in total 3 times. And in the image here, you can see the actual spider, because this victim actually had seen a report online urging people, if they're bitten by a spider, to catch that spider, otherwise it can't be verified. So she brought the spider to the hospital with her, and sure enough, it was Steatoda nobilis. But the intensity of the symptoms was quite remarkable, which developed on to cellulitis and dermatitis. Very intense treatment with antibiotics for several weeks, to the point that she was just totally unresponsive to them. And it took a long time to actually, with changing things around, to resolve this. If I remember correctly, it was something like 3 to 4 months before she was off crutches. So in this case, we need to consider that not everyone who's bitten by a false wither spider will necessarily induce a bacterial infection. Not everyone who has a bacterial infection got it from a false wither spider. Just because they think they might have been bitten by a spider doesn't corroborate this either. But we need to realize that the potential for them to vector bacteria is real. It's there. It is more likely when a spider bites, inserts their fangs into your flesh, injects venom, and transmits bacteria. If these bacteria are pathogenic, it is more likely that they will cause the bacterial infection rather than a commensal on your skin that you rubbed on later. So it's not the victim who's dirty and unhygienic. It is a spider who has these bacteria on their fangs. One other aspect of this story is that some spiders have antimicrobial peptides in their venom, and it is believed that the venom will actually neutralize bacteria on the bite site. So we tested this, and again, we found that at least for Steatoda nobilis, the venom has absolutely no effect on bacteria. So in conclusion, Steatoda nobilis is increasing its range and population density. We look at in the UK with over 100 years where they were not problematic or alarming to anyone, to suddenly everyone is starting to take note of this. I have been talking to arachnologists as well who do express some concern that they're displacing or perhaps impacting on native spiders. But we actually don't have the quantitative data. So while I need for my the aspect of my PhD to look at the medical potential, I needed a lot of spiders, so I'm out sampling a lot and I'm kind of recording my observations. But what we really need is to collect this quantitative data so we can actually thoroughly determine, are they actually having a negative impact. My own opinion is that they probably and most likely are, and it seems to be the opinion of others. But what we should at least do is question this and establish this, and not leave it another decade or two before we realise that they are. But also the venom is actually quite interesting. It is very closely associated with a big overlap with the black widow venoms, and with a range of enzymes and neurotoxins. It's quite interesting venom. And it can induce, in some cases, latrodectus-like symptoms. And but in most cases they're mild. But also can induce very mild necrosis at the bite site, and do carry pathogenic and antibiotic-resistant bacteria on the body and the fangs. So that brings back also to some of the claims that if the person is bitten and they clean the wound, or maybe not, but it's suggested that the bacteria actually comes from commensals. But the bacteria we're finding is also on the spider's body. So these spiders are not at all aggressive. I've worked with tens of thousands of these over the last 4 years. I regularly handle them in the lab. They are not an aggressive species. They only bite when they're trapped. But it is true, if you pin these, they will bite without any hesitation. Anyone who says otherwise hasn't been working with as many as I have, because they regularly bite once you pin them down. And why shouldn't they? But if you imagine a scenario where a spider's trapped in your clothing and it feels like it's being crushed and it bites, but if the bacteria is not just on their fangs being injected, but also on their body, and that rubs off the skin area, well, isn't that also more likely to cause an infection rather than rubbing up your forearm or something and rubbing back on the wound later? But more importantly, we really need to look at the facts that it is at least potentially invasive, or has potentially invasive traits. So we really need to keep an eye on that. And then also the medical aspect. This is a species with medical significance. It's not harmless. If people have severe reactions, it is not because they're just allergic to it. That's absolutely untrue, and there's no grounds for that at all. And but it's not the villain that's made out to be. It's just by accident where in areas where population, especially areas where population density is increased, the spiders are actually finding themselves in the home and in clothing or bed sheets. It's not where it wants to be. It doesn't want to be crushed in your bed, but that's where it finds itself. And the person who's bitten is also a victim, so nobody's to blame. So we don't need to demonize the spider or demonize the victim. But we need to realize that it's not totally harmless either, and we need to kind of have a bit of an open mind and kind of strike the balance and get this right. So while my message is for folks at home, don't need to be worrying about these spiders, but our work is really to alert the medical community to try and kind of monitor these cases more vigilantly, so that we can actually build up a better idea and understanding of what the potential is for these spiders, and determine, are they the next rising health issue, or are they going to continue to be only problematic to a small few people? But it's better that this is scientifically evaluated so we know before it's too late. Just to acknowledge some people, especially my supervisor, Dr. Michelle DeGon, and a whole host of people who I've collaborated with and helped me along the way. And these are our fantastic crew in the lab, all the people we've had great times working with over the years. And if anyone has any questions, please fire away.